Hey guys, thanks for being here with me today. So today we're going to be explaining the physics behind the vertical jump. So what exactly is a vertical jump? As most of you know, a vertical jump is when you jump upwards in the upwards direction, trying to maximize height or touch a certain object. Like this. We see so many people use their vertical jump to their advantage. From John Morant and Anthony Edwards throwing down 360 dunks.
We knew he was good.
To Javier Sotomayor or Charles Austin, Olympic high jumpers hitting heights of almost 8 feet easily. 245. Why do these people jump so high? And how can we, as normal people, maximize our vertical jump? So here's the physics behind it. Okay, so one of the major things about the jump is the force that you exert on the ground, which is called the ground force reaction, which ultimately sends you into the air. Makes sense. This is because Newton's third law of motion, which states for every action there's an opposite and equal reaction. This totally makes sense, because think about this: you're sending force into the ground and it's sending it right back at you. So let's get the basics down first. A person's force without moving is measured as mass times gravity, and Earth's gravity is 9.8 meters per second squared. But gravity is also acceleration in the y direction, aka vertically. So this means our equation is currently mass times acceleration equals force. But let's get a little bit more complicated. Let's go. You ready? 1, 2, 3. So the total net force of the jump must be greater than the force of gravity. And this will equal the force of the jump. This ultimately sends you in the air. So the equation, once again, is force of ground reaction minus force of gravity equals force of the jump. But the tricky part is that this is only in the descending motion. Let's talk about the upward motion and how the descending speed affects it. Explanation coming quick. 3, 2, 1. So earlier I said that gravity is the acceleration in the y direction. Okay, so the equation was the force equals mass times acceleration. But we can also substitute this equation into force T equals mass times acceleration times time. But also acceleration times time equals velocity. So we can substitute velocity there real quick. So now, equation right here. Ft equals mass times velocity. And I would like to note real quick that in this whole jump, there's 4 different times that must be measured. Whoa, that quick explanation got me really tired. But let's talk about the upwards direction, which is used 2 times because we got to use 2 different times. So let me just sit down and explain it to you. So now with the upwards direction, we're talking about the very best part, my favorite part personally, the flight. Who doesn't like the flight, baby? Who doesn't love the flight? So to calculate this, we would do velocity times time at the peak of the jump. At the peak of it, all the way up. You understand? You do. To calculate this time peak, you would do velocity divided by acceleration. And once you find that, you can also use this to find the height of the jump. So sometimes it's going to be 30 inches, sometimes it's going to be 35, 29. It would just find you the height. And the equation for using that would be velocity squared divided by acceleration times 2. And this will give you it in meters. And finally, we will be talking about the landing next. So the landing can be calculated as mass times velocity times T4. Because I did say earlier that we can measure it in 4 parts. I know this can be very confusing to some people, but let's get some numbers and plug it to these equations. So now let's plug those numbers in. I weigh roughly what, 140 pounds, and to turn pounds into kilograms I would have to do 140 divided by 2.2, and I would get about, let's see, 64 kilograms. That makes sense. And then after that 64, I'm gonna use my calculator real quick. I would multiply that times 9.8 to get 627 newtons. That is the force of my body. And then I would subtract that from my ground force reaction, which is 3,726, and I would get 3,099. A person of my height and my stature would have to have a 2,700 to 2,800 newtons for your ground force reaction, just to touch 10 feet. And that's roughly a 26 to 27 inch vertical. But now to calculate the peak of my jump, I would do 64 times 9.8 times time. And this is only for the downwards part, for the downward speed. So let me see. Ready, set. Ooh, that's pretty fast. 0.34. Multiply that, I get 0.1. My fault. 2.13 meters a second. That's how much I'm going downwards. I'll do the same thing to calculate the total time. So I'll do this to that, 0.69. Then I would multiply 0.69 times 9.8. I would square that. Then I would divide it over 9.8 times 2. And I would get 0.33. That's how many meters I was in the air. I would have been in the air. But enough of that. Let me tell you a couple exercises you can do. So a couple exercises you can do is you can get some dumbbells. Probably lightweight, from 10 pounds to 5 pounds. That's pretty good. And then you want to get in an athletic position and then just jump. This will increase your vertical. Next, you might just want to do a couple of these. This would help too, but you would want to increase the weight. And finally, I like this, a little bit of triple jump with it. You go 1, 2, 3. That would also help you increase it. These are just a couple of exercises to help you increase your vertical. Thanks for watching, and thanks for learning about all the physics behind the vertical jump.